we'll see the next question, question number 12. Find the sum of 1 square plus 2 square plus 3 square up to 100 square. So we'll see the working. So we can use the summation formula to find the sum, and we know sum of natural numbers, that is sigma n square, that is 1 square plus 2 square up to n square. So it is n into n plus 1 into 2n plus 1 by 6. So here our question is to find squares of numbers, sum of squares of numbers up to 100. So substituting 100 for n, so 100 into n plus 1, 100 plus 1, that is 101, and 200 plus 1, so 201 by 6. And simplifying this with 3, so find the product and then divide it with 2. So 101 into 67, 67 into 100 by 2. So which is equal to So answer for question number 12 is option A, 33, 83, 50. So to find sum of squares of numbers or n natural numbers, so we can use the formula n into n plus 1 into 2n plus 1 by 6. So the next question, question number 13. So find the sum of 5 cube plus 6 cube plus 7 cube up to 21 cube. So we'll see the working. So sum of cubes, so we need to find cube of, so sum of cubes of 5 cube, 6 cube up to 21 cube. So we have cubes of, sum of cubes of natural numbers as, that is 1 cube, so n into n plus 1 by 2, the whole square. So this summation starts from 1, but we have the sum starting from 5. So we'll find the sum of numbers, sum of cubes of numbers from 1 to 21. So from that we subtract sum of cubes of first 4 numbers. So proceeding as, so finding this sum, so from this we subtract cube of the first 4 numbers, sum of cube of first 4 numbers. So here using the summation formula, use 21 for n and find the sum, and sum of cubes of first 4 numbers is 100. So using the same formula, or cubes of first 4 numbers is 100. So now we'll find sum of this cubes up to 21. So n into, so n is 21, n plus 1 22 by 2 the whole square. So multiplying this with 11 and taking square, so we have, so sum of cubes of 21 numbers of 53,361. So from this sum, so we subtract 100, so which will give you sum of cubes of 5 to 21. So minus cubes of first 4 numbers and answer for question number 13 is option B, 53, 26, 1. So to find cubes of natural numbers up to n, use the formula n into n plus 1 by 2 the whole square. So the next question, question number 14. If the sum of cubes of first n natural numbers is 30, 25, what will be the sum of those numbers? So we'll see the working. So we'll see what is the relation between sum of natural numbers and sum of cubes of those numbers. So sum of natural numbers up to n is equal to n into n plus 1 by 2. So if the same numbers, if it is cubed and sum is found, so 1 cube, 2 cube. So the formula to find sum of their cubes is n into n plus 1 by 2 the whole square. So now sum of cubes of numbers is given. We have to find sum of those numbers. So when you check this, so this cube sum, when you take square root, you get sum of those numbers. Or suppose if sum of numbers is given, so when you square it, you get sum of those cubes. So here n into n plus 1 by 2 the whole square is given as 30, 25. So to find sum of these natural numbers, that is n into n plus 1 by 2, so we take square root on either side. So it is 30, 25. And now to find square root for 30, 25. We have to find square root for 30, 25. So whenever you have 25 as the last two numbers, so square root will be 5. And splitting this into 2 from right to left, you check which square number is contained in 30. So 5 square is 25. So on the tens place will be 5. So square root for 30, 25 is 55. And sum of those numbers is also equal to 55. And answer for question number 14 is option C, 55. And the workings is as follows. So the next question, question number 15. So find the sum of 1 plus 3 plus 5 up to 50 terms. So we'll see the working. Say for example, so if you are asked to find sum of 5 odd numbers, so it is 1 plus 3 plus 5 plus 7 plus 9. So up to 9 we find the sum, so which is equal to 25. So if you are asked to find sum of odd numbers up to 25, so this is equal to 9. Here 5 terms and here it is up to 5. So to find sum of odd numbers for 5 terms, it is 25. So which is got by just squaring the number of terms. So when you are asked to find sum of odd numbers up to 5, so here, so n is 5 plus 1 by 2 the whole square. So when number of terms is given, so just square it, you get the sum. So if it is given up to n, so here up to 5, so n plus 1, 5 plus 1 by 2 the whole square will give you the sum. So this is equal to 25. So 6 by 2 the whole square, or 3 square 9. So to find sum of odd numbers up to n terms, so it will be just n square. So if you are asked to find sum of odd numbers up to n, so it is n plus 1 by 2 the whole square. So now in our question, so we are asked to find sum of odd numbers as number of terms is given, so just squaring this we get the sum, so which is equal to 25 hundredths. And answer for question number 15 is option A, 25 hundredths. And formula for calculating sum of n terms, odd numbers of n terms is n square. So we'll see the next question, question number 16. So find the sum of 2 plus 4 plus 6 up to 60. So in this, as all the terms are multiples of 2, so taking this 2 common, so this is sum of natural numbers up to 30. So using n into n plus 1 by 2 and substituting for n 30 into 31 by 2, so which is equal to 930. So sum of 2 plus 4 plus 6 up to 60 is 930. So when you are asked to find sum of even numbers up to n, so as it is an even number, multiple of 2, so taking this 2 common, that is up to n. So using the summation for natural numbers, so for finding sum of even numbers, you see how many terms are there and use n into n plus 1. So here 2 plus 4 up to 60, so we have 30 terms. So in this we have 30 terms, so n is 30 into 31, so which is equal to 930. So answer for question number 16 is option A, 930. And the shortcut here is to find sum of even numbers, so just use n into n plus 1, where n is number of terms.